Factories just got a robot with 6 arms that outworks humans. A humanoid in the UK learned how to walk in 48 hours. MIT built a system that turns spoken words into real objects. And in China, an AI traffic cop is already directing cars on public streets. None of this is a concept. It's all real, so let's talk about it. Alright, let's start with what just happened in China because this one sets the tone for everything else. Last week at the Greater Bay Area New Economy Forum on December 5, Medea Group quietly unveiled something that feels like a turning point for factory robotics. The robot is called MIRO U, and calling it a humanoid almost undersells what it actually is. This thing has a humanoid head and torso, so it lines up perfectly with human-height workstations. But instead of 2 arms, it has 6 fully actuated bionic limbs. 6. The goal here was never to copy human motion. The goal was output. MIRO U is built on a wheeled chassis, which already tells you where Medea's head is at. Wheels mean fast repositioning, stability, and zero concern about balance. On top of that, base sits a vertical lifting system that lets the robot adjust height smoothly, plus full 360-degree in-place rotation, so it can spin, lift, reach, and swap tools without backing up or reorienting the whole body. According to Wei Chang, Medea Group's vice president and CTO, this robot deliberately breaks away from the industry obsession with human mimicry. His words were very clear. The value of MIRO U comes from moving past form imitation and pushing for real operational efficiency in industrial scenarios. And you can see that philosophy baked into the design. The lower limbs handle heavy components, lifting and positioning them with stability, while the upper limbs focus on fine assembly, fastening, and precision tasks, 3 tasks at once in the same workspace. At the launch event, Chang openly called MIRO U a super-humanoid, and for once that label actually fits. This isn't a lab demo meant to look futuristic. This robot is already scheduled to roll into the Medea Wuxi high-end washing machine factory in Jiangsu province by the end of the month for pilot testing. Not next year, not someday. This month, Medea expects MIRO U to boost production line changeover efficiency by around 30% once it's fully integrated. That number matters, because changeovers are where factories lose time, money, and consistency. Usually, you need multiple workers or several different machines to handle transitions between tasks. MIRO U does it alone, thanks to its rotation, lifting system, and rapid tool swapping. What also matters here is what this says about Medea's long-term strategy. The company has now officially split its humanoid development into 2 tracks. The MIRO series is focused entirely on industrial use cases like this one, while a second line called Mela is being built for lighter-duty service roles. Those Mela robots are bipedal and designed for commercial and home environments, with plans to deploy them in Medea retail stores in 2026. They'll guide customers, run DMOS, and interact directly with the public. This push did not come out of nowhere. Medea acquired German robotics giant KUKA back in 2017, giving it deep access to industrial automation expertise. In 2022, it received approval to establish the State-Key Laboratory for high-end heavy-duty robots and the Blue-Orange Laboratory. Then in 2024, it launched its Humanoid Robot Innovation Center. MIRO U is reportedly the 3rd generation in Medea's humanoid line. And according to Wei Chang, it's the first robot in the world to surpass human physical limits, while still fitting seamlessly into workstations designed for people. Now let's jump continents because something very different but equally telling just happened in the UK. A London-based company called Humanoid revealed its first bipedal robot, the HMND-01 Alpha bipedal, and the headline number alone grabbed attention. This robot learned to walk just 48 hours after final assembly. Humans take around a year to get there. In robotics, stable bipedal walking usually takes weeks or months of tuning. Alpha did it in 2 days. Even more interesting is how fast the entire project moved. From initial design to a working prototype took just 5 months. The industry average sits somewhere between 18 and 24 months. That speed came from a heavy reliance on simulation. Humanoid used NVIDIA's IsaacSim and IsaacLab to compress roughly 19 months of conventional locomotion training into 2 days of virtual reinforcement learning. By the time Alpha stood on its own 2 feet, it had already accumulated millions of seconds of simulated experience. Alpha stands 179 centimeters tall, or about 5 feet 10 inches, and can carry up to 15 kilograms with its bimanual payload. It has 29 degrees of freedom, excluding end effectors, which gives it a wide range of motion. The hands are modular, so they can be swapped between 5-fingered dexterous hands with 12 degrees of freedom or simple 1 degree of freedom parallel grippers, depending on the task. The sensor suite is dense. The head alone includes 6 RGB cameras, 2 depth sensors, and a 6-microphone array. The body adds haptic sensors, force and torque sensors, and joint torque feedback. All of this runs on NVIDIA Jetson Orin AGX hardware paired with Intel i9 processors. Power comes from a swappable battery system that delivers about 3 hours of runtime, which is clearly aimed at testing and development rather than full-day deployment, at least for now. According to Artem Sokolov, Humanoid's founder and CEO, Alpha can walk in straight and curved paths, turn in place, sidestep, squat, hop, run, recover from pushes, and perform precise manipulation. In simulation, the robot trained on more than 52.5 million seconds of locomotion data. In the real world, it took its first steps after just 3.2 million seconds of training, with minimal randomization needed to handle external pushes of up to 350 newtons. Humanoid's vision for Alpha spans industrial, service, and domestic environments. Sokolov pointed out that manufacturing sectors face labor shortages of up to 27% in some regions, leaving massive gaps in production. Alpha is designed to step into physically demanding or repetitive roles, while also opening the door to home assistance for elderly people or those with physical limitations. What's important context here is that Alpha is not Humanoid's first robot. The company launched a wheeled mobile manipulator earlier, also called HMND-01 Alpha. That decision was deliberate. A wheeled robot reaches market faster, relies on well-understood safety principles, and separates balance challenges from manipulation. Many warehouses and factories are flat, single-level environments where wheels work perfectly well, and most handled items weigh under 15 kilograms. Legs simply are not required for most real-world tasks. The lessons learned from that wheeled platform fed directly into the bipedal version. Humanoid designed its subsystems with modularity from day one, reusing components like the head, torso, and arms across platforms. That approach shaved months off development time. On the business side, Humanoid was founded in 2024 and has raised $50 million in founder-led capital. The company reports 19,500 pre-orders, 4 completed proof-of-concept deployments, and 3 more currently ongoing. It's already fully booked for early 2026 POCs and is focusing on long-term partnerships and scaling both its wheeled and bipedal platforms toward beta deployment. Safety also plays a central role in their pitch. Sokolov emphasized compliance with EU regulations covering machinery, electrical systems, EMC, radio equipment, batteries, workplace health, and data protection. The company claims adherence to the EU AI Act GDPR and broader data security standards, positioning itself as a second mover that benefits from avoiding early industry mistakes. Now, while factories and humanoids are evolving fast, something equally disruptive is happening at the intersection of AI and physical creation. Researchers at MIT have built what they describe as a speech-to-reality system. The idea is straightforward but powerful. A user verbally requests an object and the system creates it within minutes, not a 3D render, a real, physical object. The system combines speech recognition, a large language model, 3D generative AI, geometric processing, and robotic fabrication. Together, these components translate natural language into a manufacturable design and then into a finished object. So far, the system has produced functional furniture like stools, shelves, chairs, and small tables. In testing, it also managed more decorative items, including a dog statue, which hints at more complex geometry handling. This project moves generative AI beyond screens and into physical space. The researchers describe it as a step toward on-demand physical fabrication, where verbal intent becomes tangible output. The pipeline matters here. Speech input gets parsed semantically. The language model interprets constraints and intent. The generative model creates a 3D structure. Geometric processing ensures stability and manufacturability, and robotic systems handle the actual fabrication. Even though the article cuts off before diving deeper into hardware specifics, the implication is clear. This is not about replacing factories overnight, it's about collapsing the gap between idea and object. The same way text-to-image and text-to-video collapsed creative timelines, speech-to-object systems could do the same for physical goods, especially in prototyping, custom furniture, and small-batch manufacturing. Now let's take all of that and drop it onto a public street, because that's exactly what happened in Hangzhou. In the Binjiang district of Hangzhou City, at the intersection of Bincheng Road and Cheng Road, a humanoid traffic robot called Hanxing No One has officially started duty. This is not a promotional stunt tucked away in a demo zone. It's out there with real traffic. The robot syncs directly with traffic lights and wears the familiar fluorescent green uniform associated with traffic police. It moves on omnidirectional wheels and uses smooth, precise gestures to signal drivers and pedestrians. Beyond hand signals, It actively detects traffic violations, including helmet noncompliance and over-the-line parking. When it spots an issue, it sends reminders in a polite, patient tone. According to Zhang Wanj from the Binjiang Traffic Police Brigade, real traffic officers' command gestures and on-site management experience were used as training material for the robot. By integrating real-world intersection data, Hangsing No One has steadily improved its performance. It can switch seamlessly between traffic guidance and civil persuasion modes, adjusting its behavior based on traffic light states and real-time conditions. Field testing started back in October at several junctions in the district. Based on those results, authorities plan to expand deployment to more locations across Hangzhou, including high-profile areas like Westlake and Kaianjiang New Town. Future upgrades are already planned. Large language models will be integrated to enable voice interaction and command-based control. That opens the door to public services like route inquiries, traffic advisories, and safety education. Hangzhou Traffic Police are also developing next-generation robots and exploring the formation of a full AI traffic management robot team. None of this feels experimental anymore. These systems are piloting, deploying, and scaling right now. That's where I'll leave it. If you want more deep dives like this, you know what to do. Thanks for watching, and I'll catch you in the next one.